Hello, my name is Jillian. I'm a senior at the St. Helens High School, and I'm pleased to be here today with Tim Paul from Autodesk as part of our Manufacturing Month interview series. Tim is passionate about being a competitive person who loves making things and sharing what he's learned with others. For more than 20 years in manufacturing, Tim has worked in large and small companies and even owned his own business. Now at Autodesk, Tim is a technical program manager. Thank you for joining us, or Tim, thank you for joining us today.
Yeah, thanks for having me. Thanks for having me.
What drove you to passionate wise the manufacturing industry, and then on top of that the path you got into Autodesk?
Yeah, so that's a good question. So I think it's important to be successful at something to at least have some kind of passion or something that feeds you. Some people are really skilled at just doing things they just don't care about and doing them well. For me, I struggle at doing things I'm not passionate about, but I find it really easy to just dive headfirst into something I'm passionate about. So, since I was a little kid, I just wanted to take all my, little Legos and erector sets and make things, and always wanted to kind of invent. I wanted to be an inventor, whatever that means, when I was a kid. So, um, that kind of led me to wanting to learn how to make things. And then the more the more I learned about making things, the more I wanted to learn. So it kind of fed itself. I think about it like nuclear fusion, right? Like once you start it, you just can't stop it. And that led me to be a 4-year metal shop kid in high school. And then after high school, I got into the bicycle industry. And that's when I was first exposed to like modern manufacturing. And when I I was at a bicycle company down in Southern California, I first saw a CNC machine cutting bicycle parts. And I remember just spending a couple seconds watching it, thinking like, this was the first time in my life, like this is what I'm supposed to be doing, right? I'd wanted to be a mountain bike racer, and I tried, but I wasn't meant to be a mountain bike racer. I'm a more of a mediocre football player body, but wasn't really meant to be a mountain biker. So, anyways, I started going to school to learn more about that at a local community college, and then from there, I got a job in the industry as a machinist. And I've kind of filled most every position in a machine shop, from pretty much a floor sweeper up through kind of shop manager. So um, really, it was just the passion that was inside me for making things and fixing things.
Wow. And so, which leads me to my next question: where would you use CAD and CAM in the manufacturing field? Because I know it could be used for very high end stuff and easily to the low end. It can be because it's such a open, used thing, or is it just very select?
Yeah, so it's becoming not to pitch Fusion, but Fusion has become so accessible that modern powerful CAD and CAM tools have become really spread out. It used to be when I was starting my career back in the late 90s. CAD and CAM were like two-dimensional CAD, and then CAM was like, people jokingly call it handy cam, because you would use your hands and type the code. And that's when I started programming machines, was when I would write out the G code. So that's every move that the machine has to make is code that I wrote. So now with tools like Fusion, you take really powerful CAD tools, which were only used by General Motors and aerospace companies. And now people that have ideas can quickly get ideas out of their head into a 3D space and see how parts fit together and whatnot. Now, career and job wise, it's used, it used to be, used by draftsmen and engineers regarding CAD. And that's becoming more broad and more broad and more broad. So you're seeing it become more like, industrial designers are actually using CAD tools now, where they used to use like artist tools before. CAM tools, being a machinist is kind of the obvious one, but with how accessible the tools are these days, you see more and more like businesses starting up around, technology that is so accessible. So somebody that's racing mountain bikes and has an idea for a new widget. It's pretty easy to just go start that company, get those ideas out of your head into reality. Does that answer the question?
Yeah, actually, that answered really well. So someone like who has like worked throughout like the manufacturing industry, like what types of skills are extremely important for someone to get to like the CAD CAM area? Like to make like cool and or useful things.
Okay. Yeah. So skills. If you haven't found the theme yet, but I think there's just a passion for wanting to be good at what you do is like, maybe it's not a skill, it's a trait, right? But I think you start there. But as far as like technical skills, right? I think I mentioned earlier math. When I was in high school, I was like trying to do the least amount of work possible. And later on, I realized it kind of bit me because, math skills, you don't need to be, a mathematician. But I think good practical math skills, some trigonometry, things like that, will really help you when you're designing things to understand, once you learn trig, it's like everything's triangles. Everything can be solved with triangles, right? But then other than that, just knowing how things fit together, when you take something apart or build something with an erector set or join a robotics team like yourself, you'll find out real easy, like, oh, you don't think about how things interfere with each other when they're going through motion until you've made a couple bad parts, right?
Yeah.
Does that all make sense?
Yeah, and you always have to do like a trial and error, but it's seeing it in a 3D space before making it can also I can see save time, so you can see that, oh, we actually need to round out something because it's going to interfere with the bottom with something else.
Yeah, and that's something that CAD tools, when I was a kid making a stand for my motorcycle, like you have it in your head and you make it, and then you go to put your motorcycle on there and realize like, oh, it's something, it's wobbly because I didn't think about that thing, right?
Yeah,
When it's in a CAD space, it's not free because your time's not free, but it kind of trial and error is the word that you mentioned. I think it puts the trial and error in kind of a virtual digital space a lot of the times.
versus
And then you apply your trial and error of all the trials and errors you've made over your life into that digital space and hopefully make good parts the first or at least the second time.
there's always first version and then a second version.
Yeah.
The second's always going to be better than the first because you've learned a lot.
Yeah, I know a company that they don't go to production, like customer sale production, until they say the third revision. Jay Pierce at Pierce Work Holding, he says they always, they don't accept a commercial version of their products until they've done it 3 times. So it's a kind of spin off of what you were just saying.
Yeah, which by the third time it should be almost perfect.
Nothing's ever perfect, right?
That's true. There'll always be errors that the maker will see, but not to the public.
Yeah, exactly. Yeah.
So, like, what advice do you give to high school students who'd be interested in a career in manufacturing? Would it just be like, would it be passion, like based? Like, would you have to be passionate just going into this stuff, or just trying out things and going with it?
Yeah, I think starting with a curiosity is a good place to start, right? If you're not passionate about it, but you're curious, explore it, right? I think I was probably really lucky, right? I was just I had this passion that was burning inside of me to make and fix everything at our house, right? So I think starting with curiosity, if it's something you're interested in, explore it, right? So you guys, I say you guys, I think we're all in a pretty amazing time right now. I mean, we can still function with the world being shut down. You can still learn just so much from the internet. So if you're interested in manufacturing, explore it on the internet. See if a local, machine shop or local manufacturing company would kind of show you what they do. That's probably a good place to start. And then from there's lots of ways to learn. There's formal education, a lot of great community colleges, a lot of high school programs. And then, you kind of have all these different forks along the road. I think it's very reasonable to kind of get off at whatever fork fits your life and who you are. Um, I think if you go down a path of learning how to make things and want to be a machinist, that's great. If you want to be a, you know, PhD in mechanical engineering that works on rockets and things like that, I think that's great. So there's a lot of kind of off ramps along the way in manufacturing where you can kind of fits a lot of different people.
So manufacturing is just basically a general term versus there's a lot a person can go into.
Yeah, yeah. You think about it, I mean, everything on my desk was manufactured, right?
Yeah,
Everything that makes, you know, me talking to you from 600, 700 miles away, that was manufactured from the satellite up in space, to the towers, you know, to the MacBook that I'm on. So, um, yeah, it's
that's
very,
cool.
very broad. You know, everything we eat, you know, is packaged, right? I mean, it's cut apart. Everything's made, right? Everything's
Yeah,
manufactured.
so it's just manufacturing. You typically think of a shop out in the middle of nowhere building like some sort of metal product
A
versus,
ship or a car or something like that.
yeah, not
Yeah.
like making part or small fine parts and or just designing stuff in general.
Yeah, yeah. I mean, there you open up your iPhone and look at all the tiny little things in there. You know, there's silicon wafers that were grown from nothing in a chamber. You know, a lot of that work happens in Silicon Valley, but that big chamber had to be machined, right?
Yeah,
You know, the little robot that moves the little chips, you know, and puts them on your inside your phone. That was some, you know, lots of little parts had to be
yeah,
manufactured to make that work.
just it's a lot broader than just the preconceived ideology that people have of the field,
Yeah, exactly. Yeah.
which is always nice to know that there's more options than what you think,
Yeah.
instead of just like the presets of, oh, you can only do so much and with whatever knowledge you have. It's,
Yeah, it's I've been accused of having ADD, and it's really just you know, passion and thirst for learning more, and the manufacturing industry has been able to feed that. So if you look at my resume, it's a little twisted, but it's because, you know, I learned something, I became proficient and become professional at it, and then, you know, something over there looked really interesting, so I'd go chase that and learn that, and something over there looked real interesting, so I'd go chase and learn that.
yeah, it's like I do a lot in a shop. It's just like, all right, I like this. Like I'll work. Let's see where I can take it up next. And like, can I replicate this so it looks very similar to within a certain parameter? Is
Yeah.
my whole go-to of can I get it precise and then duplicate it? So then that makes it so I can easily by hand do it on my own. And then it's like once you add a machine, that makes things so much easier. But at least I know the ideology behind it to do it myself.
Yeah, exactly. I think people like you who are dabbling with programming and making, I think you're a unicorn. I think I think you're in a good position to do some fun things in your career.
I've had all the fun's making pawns on the lathe, so all
Awesome.
by hand.
That's
The
awesome.
hardest part on that is the rounding off the top for the pawn,
Hmm.
but
How do you do that?
lots and lots of patience
Okay.
and drive for it. It's very much trial and error, and then school shut down.
Oh,
So I couldn't even finish like my first one going into the second one. I
yeah.
wanted to be able to see like how close can I get it to the first one. That
Hmm.
was the whole point of my project too, is precision and accuracy
Good,
off my own design.
good. Are you cutting the round shape with a shaped tool, or are you moving the hand because you're doing it
I,
by hand, right?
yeah, I'm moving everything by hand
Yeah.
and
Like
then stopping every so often, checking measurements.
good. So you're moving it around like an etch a sketch.
Yep.
Oh, that's awesome. That's awesome.
Yeah,
Well, great. What else you got?
that's about it. So thank you, Tim, for speaking with us today as part of our Manufacturing Month series. It has been great to learn about you and your career and that you have Autodesk. If you're interested to learn more about Autodesk, please go to their website at www.autodesk.com. And thank you for watching. I hope you enjoyed this conversation with Tim, and I wish you all a great manufacturing month.
Thank you.
Welcome.